Hello, hi, welcome everyone. Thank you for joining us today. Um, Myself, Harshit Gupta from Data Couch. I'm thrilled to welcome you all for today's session on improving Snowflake performance using clustering techniques. In today's rapid evolving landscape, organizations are dealing with increased data volume, growing analytical demands, and the need for real time insights. As data environments become more and more complex, Snowflake help us in ensuring that workload which are there on these platforms are performing optimally, and they are not just working optimally, but they are beneficial in terms of costing perspective as well. So Snowflake provides us this remarkable scalability and flexibility, which is out of the box. But true performance efficiencies comes from understanding and leveraging its deeper capabilities. And one of such capability is clustering. That is what we are going to cover in this session today. Let's see now what we are going to cover today. So today, first of all, we are going to talk about why performance and clustering matters. What is clustering within Snowflake? When do we need clustering? How Snowflake clustering improves query performances? What are the types of clustering? And we will be looking around a demo around all of these things, and then we'll open the dais for question and answers. And in between as well, if you would be having any questions, queries, anything, please feel free to drop your queries within the chat. I would be more than happy to answer those queries. Why performance matters? Why performance matters? Or let me start with a very simple question. If two companies store the same data, stores the same data within Snowflake, why does one dashboard loads in 3 seconds and another dashboard is taking 30 seconds? It's the same platform, same cloud provider, same pricing models, yet widely different performances. Any thoughts? Anyone would like to share their thoughts about this, maybe in the chat, or could be anything. Why it is happening? Like one company is taking almost 3 seconds to load the same dashboard with the same data on the same platform, while other company is taking 30 seconds. Why it is? It is because in cloud, performance is not automatic. It is engineered. What we are going to talk about today is not just tuning the queries. We are going to talk about designing performances in your data models. And today, one of our most understood but powerful tools in Snowflake platform, that is clustering. That is where we are going to make our focus today. Today's focus would be on clustering, but there are many other ways with which we can engineer the performance within the Snowflake, or uh, within the Snowflake, or we can say any of the cloud-based environments. Okay, but our focus today is on the clustering, specifically on the Snowflake. There are many other things as well which can improve the performances. But yes, clustering is one of the way with which we can improve those working, or getting that data from background, and making sure we are getting those data points and pointers. We are able to create the correct dashboards and scenarios in front of us. So what performance really means in the businesses, when we talk about the business side of the performance, what does it mean? So when we say performance problem, what do business team here? They are not going to hear like, okay, we are having a very slow queries, or dashboard is slow. They'll be saying delayed decisions. There is a delay in the decisions. They're not going to say, okay, compute issues are there, or expensive compute is there. They are going to say, okay, there are going to be higher cloud bills. Reprocessing queries are happening. No. Analyst is going to frustrate. They are going to say, hey, things are not working out for me. Retry queries, user mistrust, because these dashboards are user facing or companies are using the pointers from the data set to share some insight with the clients and the users. So if there is retry queries and the insights are going to take a lot of time, business is going to get impact and user mistrust would be there. Okay, so performance in Snowflake isn't, or any platform isn't just about, how fast is my SQL, or when we say, okay, there is performance issues, the companies or the business is going to talk about, hey, my bill has gone up by 3x, while running the same query on the same data set, it has gone 3x. Data engineers will be blaming for something that is fundamentally architectural. So a lot of such kind of issues would start happening if performance has not been optimized. So that is where the performance optimization comes in. And our major scenario is, how fast can business teams trust your platform? A major question that you would like to answer: how fast can business teams trust your platform? And region, both of the fields together can bring us some better results. So from the APAC region, from the EMEA region, or from Europe region, or any other regions, we want to calculate, or we want to see, okay, how many orders, how or on which date the orders were more or less, or how were the scenarios. So not a single field, but multiple fields or columns can help us to group this data. Now, what are the benefits when we are using the clustering within the Snowflake? Snowflake users can manually define the clustering key to control Snowflake, to control how Snowflake creates micro partitions. So in Snowflake, we are going to create the micro partitions. And what are these micro partitions? As we are going to move, okay, in that case, now let's see how actually it is going to work behind the scenes. What is happening behind the scenes? Okay, so whenever we run a query, let's say in the previous scenario, we understood that, okay, there is a data set, orders data set, and there is a user which is running a query to extract the data. So what happens behind the scenes is, Snowflake does not immediately scan the data, because in Snowflake we have like automatic clustering and all other clustering scenarios as well possible. So now Snowflake, once we have uploaded the data within the Snowflake, it is automatically going to create the partitions for us. So once these partitions are created, which are known as micro partitions, Snowflake does not immediately read or immediately scan all the data. So what happens, let's say we have this data and Snowflake has already divided the data on the basis of the automatic clustering. So what will happen, it requires a key which is sequential. What is the minimum requirement here we are having? We want a sequential column. Sequential columns, what do I mean by it? Where data is coming out sequential. First of all January, February, March, like that, in sequence. If there would be unsequenced data, then like there would be some issues, but still scenarios would be possible, but issues would be there. Okay, so let's say we have this data, or we have this field available with us, create at. Now once these if you look at this data, so what Snowflake is going to do, Snowflake is going to have this data and going to store it in a particular micro partition, a micro bucket, a micro directory, a smaller file. So where we were having 100 GB of data combined together, now each of the file would be, let's say, the 10 GB, or even less than that, 1 GB of file. Now it would be very easy and very fast to read this smaller chunk of data. And every micro partition every micro partition that we are having here, every micro partition is going to store a minimum and maximum value per column. So let's say we are here having the ID, item quantity, total price, create at, all these columns are there. Each of the micro partition is going to store the minimum and maximum value, the range statistics, and the distribution information. So here we are going to have, okay, how many distinct accounts we are having, how many total price we are having, or when it was created. So we are getting a distinct count, minimum value, and maximum value of it. So now what is the benefit here? What is the benefit here? So if I have a query which is looking for uh, created at created at is greater than 2022 0 9 10, or let's say 0 9 9, and less than 2022 0 9 10. So if this is my filter, if this is my condition within the query, and I am having the minimum and maximum value, we can compare these values to these minimum and maximum value. I need not to necessarily go through the whole partition. I need not to necessarily go through the whole partition. I can simply look at the minimum value and the maximum value. So Snowflake, what it will do, as soon as we run this query, it is not going to scan the data. It is going to start scanning this metadata. What is the metadata we are scanning? The minimum value and the maximum value which are available. So it is it is going to look at these minimum and maximum values. So from there we will get to understand if data belongs to this partition or not. If it is not, it is going to move to the or it is going to skip to the next partition. So using that, Snowflake decide which partitions are relevant, which one can be skipped, which one must be scanned. And this logic of scanning is known as micro partition pruning. Micro partition pruning. And that is where clustering comes into play. And that is where clustering comes into play. Any questions before we move ahead? Before I move to the next step, what will happen once this scanning is done? And once we have decided which partitions to scan and which partitions to skip, are we clear with micro partition pruning? Any questions, any doubts before we move ahead? We get the better results. So when you are working with the clustering, especially within the Snowflake, it is not only you need to define the keys or you need to select with your correct keys. You need to also make sure what is your depth. Eventually, Snowflake will do it, but it will take some time. In between, if some of the queries have been executed, those queries can be expensive in nature. But here, once you do the reclustering, it will make sure the optimizations are done. And when you again run the queries, then there would be benefits. Then you'll see the benefits. Okay. So that is there. And talking about the two other clusterings, automatic clustering, you just need to simply set, hey, what is your table? Set automatic clustering true. So what reclustering we are talking about, it is going to take it automatically for us behind the scenes. Okay, it is going to manually evaluate your clusters. So natural clustering is going to create your clusters, and Snowflake is not going to actually refine it further. Once the clusters have been created, howsoever it has been created, it is going to be there. What automatic clustering is doing here is taking it to the next level, taking the natural clustering. And if you have, like automatic clustering set as true, then you need not to manually run the query like we were running the alter table. Then you should be going for the multiple column clustering. So these are some of the clusterings which are available that you can use. We have seen this practically as well, how Snowflake will do it. What is clustering depth? Why clustering depth is important? Okay. So this is a whole perspective around one of the optimization techniques in Snowflake, that is clustering. Forward we are going to come to that, but as of now, let's say it is small directories we are having, or the small buckets we are having, in which we are going to arrange the data. Okay, as of now, let's just understand micro partitions as small directories, or let's say we are having multiple folders with us available, in which we need to arrange the papers or the data that we are having with us. Okay, Snowflake can also automatically clusters the data into micro partitions. So it's always not necessary when we work with Snowflake that you need to manually arrange or you need to manually cluster your data. Snowflake also has the capability to automatically cluster the data, to automatically cluster the data. Such kind of, okay, great. Then I would say thank you so much, everyone, for joining this meetup session. We highly appreciate that you have taken the time to join the meetup session.